Hello, my name is Nipun Jain. I'm a technical marketing engineer in the IoT business unit in Cisco. And what you're seeing here is a representative or representation of a distribution automation utility cabinet. You see the blue SEL 651 recloser, very popular in the market with distribution automation recloser deployment. And what you see in the black, you see the black router, that's the IR1101 Cisco Catalyst IR1101 with a cellular WAN backhaul. So the WAN is likely encrypted, but the LAN inside the cabinet, the direct connection to the SEL or Ethernet is most likely not. So Cisco and SEL have worked together to encrypt the last foot using industry standards of MACsec and MKA MACsec key agreement, which are both mature IEEE standards. The result is a 128-bit AES backed encryption between the 1101 and the 651R. And any device that is basically enabled with a MACsec protocol at the layer 2 stack. So in today's standards, this would take quite a long time to brute force and crack, especially given the physical security of the cabinet added on. And what we're going to do today is we're going to show you how this MACsec interoperability is set up on both sides. Here, what we see is a potential attack vector and how it's mitigated. If the physical security of the cabinet is compromised, a wiretap could be inserted as shown here, and passively tap without unplugging any cables, or an active tap using things like MAC network substitution and other similar attacks could be used to interfere with any clear traffic. So we want to basically be able to mitigate those attacks, and that's where the encryption 128-bit AES encryption with MACsec comes into play. And if you look, the backhaul is either it could be a private LTE, public LTE, or a WAN, cellular WAN backhaul back to your data center, carrying all that, either the DNP3, communicating with the DNP3 master, or a server on that side. So let's start with that OT network flow, right? And here, as you can see, we are capturing by on Wireshark on our specific Ethernet tap that we built on our labs to look at a DA cap, the traffic between a DA SCL651 recloser and a Cisco IR1101 series industrial router. So just as an example, we can see that we are reading out some basic information from the DNP from the server side that is sending down clear text DNP3 traffic through the IR1101 and down to the recloser. This could be any traffic that is used to measure or communicate with the recloser, including temperature readings, if there is a fault on the line, and so on, or any other monitoring data that is of interest to the server that is in the data center communicating to the recloser in your distribution automation network. So just as an example, we can see that you're seeing some human readable text with DNP3 with the DNP3 protocol here, and you can see it's going through between the 1101 and the recloser. So let's change that, right? Let's figure out how we can encrypt this traffic using MACsec. So the first step is to enable MACsec on the IR1101 router that you see here. We are enabling the MACsec on its interface. You can see that it's disabled at this point. We don't have any sessions that are that are live using MACsec. So what we will do is simply configure a layer 2 interface fast Ethernet on the 1101 with a MACsec encryption protocol and a key agreement that's already been configured on the router. So this is basically done with a few additional lines of config, and once the config is in place, it's crucial to then check the config and make sure that it's still passing regular Ethernet traffic. On the SEL side, the commissioning process, we see that we are clearing the session just to be sure that we can start it up again. And we're enabling the session now with simple series of commands that will enter the basic key and then the CAK or the connectivity association key. And then that will basically enable the key server agreement and start communicating with the 1101. So what you can see here, it's trying to make that connectivity association with the 1101. And once it successfully secured a session, it's going to show that. And we come back to the 1101 to see that the session has been enabled on MACsec. So if you look at this, the 1101, we can see that we've secured the link between the recloser and the 1101, and it's an active MACsec session now. So now back to the Wireshark session, we can see the transition point where the control plane the traffic has been switched to a MACsec frame and has been encrypted. So we see all the headers of the IPTCP UDP headers are now hidden as payload and are now meaningless, characters in that frame, right? So you can see that it's being encrypted between the Cisco box and the SEL box. So that in effect is how the process is working. And how do we know? Looking at again at the DNP3 master, we are seeing it's still the polling is still successful, and and we are getting encrypted DNP3 traffic. So in summary, Cisco and SEL have worked together to encrypt the last foot using industry standards of MACsec and MACsec key agreements, and this will result in strong encryption with